We're going to be continuing our practice from the tech interview guide, tech interview handbooks, study guides. Today we're going to be starting the topic hash tables. The hash tables has two essential questions in the guide, but after already done one of them, that was two sum. If you want to refer to those questions, please look at the array essential questions playlist on the video playlist section of my channel. And today we'll be doing ransom node. It's an easy question. Let's read. Given two strings, ransom node and magazine, return true if ransom node can be constructed by using letters from magazine and false otherwise. Each letter in magazine can only be used once in ransom node. Okay. Each letter in magazine can only be used once in ransom node. Okay, so that kind of sounds simple. This line really makes it simple. But if we had been given it can be used multiple times, then this wouldn't be a hash map question. Okay, so when our input ransom node is A and magazine is B, it doesn't exist in magazine. A doesn't exist in B, so we have to return false. Same kind of example here. In example 3, we have ransom node as AA and magazine as AAB. That means we can take these two A's here and we can form ransom node, and then we can return true. Constraints. Okay, it's greater than 1 and less than equal to 10 to the power 5, and ransom node and magazine consist of lowercase English characters. Okay, so this sounds like a pretty simple question. It has a couple of different solutions. In one of the solutions we use hash map, so I'll be going through that kind of solution. So in the hash map method, we can use two hash maps or one hash map. I'll show that to you in the scratchpad. Let's jump in. Okay, so let's get started. So we have a couple of different solutions here. This one has for one hash map. This is for two hash maps. Let's look at the first solution. So if you want to use one hash map, which I personally think is more efficient than the two hash map, but we can argue about that. If you want to use one hash maps, we would initialize a hash map, magazine hash map, and then we'd go through the magazine string, and then when we're here, we would check if the value is in magazine hash map. If not, we initialize it to 1 count. We see another A. We see if it's there. If it is, we update the value. It is there. And then we see a new value here, B. We can initialize it as 1. Once we have the entire hash map ready, we can now parse through ransom node. So while parsing through ransom node, when we see an element, we would check if it's in the magazine hash map here, and if it is, we would update the counter of this as -1. We would subtract. That means we have seen one of the A's in our ransom node, and we have to subtract it here so that next time when we come across, we can make sure it's not 0, and if it is, we can return false. So now we see another A and it is there, so this will become 0. We're still fine. If suppose we had another A in here, we would check if A is an element in the hash map. It is, and then we would check if A is actually 0. If it is, we'd simply return false. Okay, suppose there was an element B and A again. we would go check if b is in the hash map. If it is, we would reduce the value. B is now 0, and that's how it works. We would, if everything passes, we just return true directly. It may be a little bit confusing here, but I assure you, when I write the code, it will be as clear as possible. Then we have the two hash map solution, right? So here also we'd be making a magazine hash map that would contain all the elements. We would first build this out. So this would be A is 2, B is 1, and then we would make the same similar kind of hash map for ransom node, and we would call it, we would initialize that A is 2, as we can see here. Okay, once we have these two, we can parse through all the key values in ransom. Okay, so there's only one key value, and once we have the key, we can check its value. Okay, it's 2, and now we can check if A exists in magazine. Okay, and if it does exist, we check if value is less than or equal to magazine value. And if it is, that means that round of checks are fine. If at any point this condition fails, we return false. Clear? I hope it is. Let's jump back into Leetcode and try to code this out. One hash map solution. So for that we needed a magazine dictionary, magazine dict, which would be mapping from character to int, and let's initialize it to be empty. Okay, and we also want to check if the number of elements, number of characters in ransom node is always less than or equal to number of elements in magazine node, magazines. So if you think about it, if this has, so if you think about it, if magazine has less elements than ransom node, then it would most definitely mean that ransom node cannot be constructed, right, from magazine. So we would do guard ransom node dot count is less than or equal to magazine dot count, else return false. Okay, now once we have the edge cases covered, we want to parse through all of the letters in magazine. So for letter in magazine, now we want to check if magazine dictionary already has that letter. So if let, if no, you don't need let, magazine dict of letter is not equal to nil, magazine dict of letter plus equals to I, and since we are sure that we'd be getting something from here, since we're not using any if let or guard statements, we have to force unwrap this part of it. Else, if it's already there in magazine dictionary, then we can just go ahead and update it, right? So magazine dict of letter equals to 1. Oh no, sorry, this is for updating, this is for initializing. Okay, so now this block of code builds out magazine dictionary. At this point, line 17, we already have the magazine dictionary. So now what we can do is we can parse through ransom node and check if there is some value for that particular letter in ransom node in magazine dictionary, and that value is not equal to 0. So let's do that. For letter in ransom node, if let, now here we can use if let car count, since we'll be using car count. equals to magazine dict of letter. If there is some value in magazine dict for this letter, and car count is not equal to 0. Okay, let's put down an else statement for also for this. Now if there is no letter, we want to return false. And if there is a letter and the character count is 0, that means we've already run out of all the characters for constructing ransom node. So in either of the cases, we return false in the else part. In the main working part, what we have to do is we have to decrement magazine dictionary's letter, which is also force unwrap, minus equals to 1. So what this would do is if the value is always greater than 0 and there is a letter in magazine dict for our letter in ransom node, then we want to decrement that value. So for the next time, we will always know that we have these many characters left, since we can only use each letter only once. And if that passes through and it doesn't return anything, what we can do is basically return true, and that's it. This should run. Let's give it a spin. Okay, that runs. Run the test cases, submit it. Okay, that's the solution for doing this ransom node question with one hash map. How about we look at another method? Let's clear this out. Okay, so this is for 2 hash maps. Actually, I kind of needed these things. Let's just copy this and this. Okay, and then reset it. Okay, so we have magazine dict, and copy this down. Okay, we are making another dictionary, right? Ransom dict, which is all exactly the same thing. We also can check for the guard statement. So that's ransom nodes.count. I could have copied that, equals to magazine.count, else return false. So now this is building up the magazine dict. In the same way, we can build out the ransom node. So ransom node, this is the magazine and the ransom dictionary. Yeah, and that builds out the dictionary for ransom node. Now what we can do is we can parse through all of the keys in ransom dict, and we can check if the count, that same letter exists in magazine dictionary, and that dictionary that letter's value is less than whatever the value it is in ransom dict. Let's put that down in code. For key in ransom dictionary dot keys, that's how you get all of the values for keys. Guard let magazine car count equals to magazine dict of key, else return false. That's one of the ways it can get out. Then we check if magazine, this one, magazine car count is less than ransom dictionary of key. We have to force unwrap it, and if it is, we return false. Now here we already know that this key is coming from ransom dictionary, so we can force unwrap it here. And magazine car count is less than this value. Only then we can confirm that this particular key can be, this particular ransom node can be built by one of the characters in magazine dictionary. So if these two pass, and it doesn't break away, we just simply return true. Okay, that worked. Okay, that worked too. Let's look at this. Okay, awesome. That worked. So for both of these, the time complexity is O of n, where n is actually the count of these two based on whichever one is bigger. So if ransom node.count is bigger, this n belongs to ransom node. If ransom node of magazine, if magazine.count is bigger, then n is magazine.count. And space is again O of 1, since we're always mapping finite number of characters and we're only incrementing the count, it will always be O of 1. We'll be running that in linear time, constant time. Okay, and that's the solution. If you learned something from this, please do give it a like and consider subscribing. I will be posting more videos in the coming days. Thank you.